Alrighty, so recap. I had you draw triangle ABC. And then we located what after you drew this triangle? The what? Midpoints. You found the midpoints. Then, what we did is we drew in our medians, because we know by definition what a median does is connects a vertex to the opposite side's midpoint. So once we located those three midpoints, we can easily draw in those medians. Then we know that the medians are concurrent, which means they're going to intersect at one point. Now, that point of concurrency for the medians is called the centroid. We had triangle ABC. We named our midpoints M, N, and P. So because C was already taken, I just used a random letter and just said this is point Q is our centroid. Okay, now, where are those marks of congruency that we absolutely know we can add into this diagram? Can someone tell me a set of congruent segments? Grace, what's up?
Segment AM is congruent to segment MB.
Why?
Because the definition of midpoint.
Right, midpoint, right? We know that those are the midpoints. The definition of midpoint says that it bisects that segment. Bisect means to cut into two congruent parts. And then we can continue going because we know that these other midpoints here. Is my diagram okay?
No.
No, it is not, because this conveys that all the sides are congruent. We don't know that. So you need to differentiate your different sets of congruent segments. Alrighty. Now, from there, that's information that we have already known for a long time. Now it's new information about these medians. Now, do you see how the centroid breaks up each median into two pieces? You see that? Okay. Now, on your sheet of paper or up on the board, focus on one median. I'm going to focus on the green one. Do you see how the centroid, yes, it breaks it up into two parts, but one part is obviously larger than the other. Do you see that? The part that will always be larger than the other part is the segment that goes from vertex to the centroid. That piece of the median from vertex to centroid will always be longer than the other piece that goes from midpoint to centroid. And the way that it'll always be broken up, I'm talking about the whole thing, the larger piece will always be 2/3 of the whole thing, leaving 1/3 left over. So this is how the whole median is being broken up by that centroid. This happens to every single median, in every single triangle. The centroid will break the whole median into two parts, one being 2/3 and the other being 1/3. Add them up, you get a whole. Okay? Now, I don't want anyone to yell anything out, but I want you to think to yourself, how are these parts related to one another? What is the relationship between these lengths? We're no longer comparing it to the whole, because yes, this is 2/3 of the whole, and this is 1/3 of the whole. Okay, we're done with that. Now, start thinking, well, how is this segment, this piece, related to this piece? Could you describe that relationship? And so I want you to think about that. And then I want you to give me, like let's say this was X, then I want you to give me some representation for this length. So please think about that on your own. What is the relationship between this piece and that piece? That's always going to be true. Then take that and apply it to the red median and give me some representation for the length of this other piece in terms of X. So I want you to think about that on your own. First off, I want to hear the relationship between these two parts. Who's got it?
The larger part is 2 times as large as the smaller part.
Perfect. This piece here that goes from the vertex to the centroid, that's always going to be twice as long as this piece, because 2/3 is double 1/3, right? So if there's 3 markers, 2/3 of them are in my left hand, and 1/3 is in my right hand. So that I have twice as many over here than I do here. So if this portion of this median is labeled X, then what could I label this? 2X. Right? And so that's how the pieces relate to one another. same exact concept, but just a little different perspective. What if I labeled or gave you this length of the longer piece, let's say it was y, how could you represent the shorter piece?
1
1/2 y. Wonderful. Okay. This information needs to be written and drawn in your diagram. You need to know how this centroid breaks up these medians. Now what we're going to do is I'm going to project some scenarios up on the board. So I'm going to give you, like, let's say the length of segment AN is equal to 27. Then what would be the length of NQ? Okay? 9. But anyways, so I'm going to project some scenarios, and that's exactly what we're going to do, okay? None of the scenarios relate to one another, so don't take information from the first and try to use that for like the fourth one or whatever. So, oh, that's crazy close. Anyways, sorry, here are your 5 scenarios. Let me erase the board. And I want you to copy these down to the right or below or somewhere near your diagram that we just got done creating. These are the 5 scenarios. First one, what if the length of segment AN was 12? Then, what would that force the length of segment AQ to be? And so on and so forth. So go ahead and copy those down. Once you've got the 5 copied down, then we're going to, I need your supplement. But copy them down first, please. Thank you.